Welcome to this screen recording of a full turbine capture mission using Dronebase's Autoflight software. I'm just adjusting the window in the bottom left hand corner to show the FPV view, and I'm going to turn that off and press the file button in the bottom right hand corner to bring up the closest turbine site, which is Braes of Doon, which is where I am, and select turbine 32, which is next to me, and press open once I'm happy with the details. Then I can press the blue tick button, the check mark in the bottom right hand corner, to bring up the crosshairs. I'm going to do my final pre-flight checks, and now I'm ready to take off. Now I've taken off, and I'm going to be angling the camera down using the gimbal control to point at a blade card, and the blade card is a record of this particular turbine, the date and time and other details. I'll be taking 2 photographs of that, and they form part of the data set, so I can see immediately when I'm looking at my SD card the breakpoint between each set of images that I've captured. You probably saw that I also briefly adjusted the focus to make sure it's at the infinity point for the distance we've selected. And I'm going to climb the drone up, skipping a bit and getting ourselves to the front of the turbine, around about 60 or 70 meters away, so that we can clearly see the alignment of the drone in front of the turbine and the alignment of the blades when we get to that point in the process. So I'm very carefully looking to make sure that the drone is absolutely in front of the turbine. You can use clues like the anemometers, the superstructure above the top of the turbine, to help you in deciding that you're exactly in front. And once you're happy that you're exactly in front and that the drone is stabilized, the camera is stabilized, and you're ready, you can press the green blue tick mark in the bottom right hand corner, which will bring up the alignment wizard, and we need to be aligning the ABC with the blades themselves. Just below where it says sequence ABC, we can use those 2 buttons to make fine adjustments in 0.2 degree increments, so that we've got our alignment tool in alignment with the blades on the turbine. When we're happy with that, we press the blue tick mark again, and we fly up to the front of the turbine hub, just by eye, not looking at the screen. Just watch the drone fly up to the front of the turbine, stop in plenty of time, around about 10 meters from the hub, and then we can do the final part of the alignment. So again, I'm moving the drone with the right hand stick I'm not yawing, I'm moving it to make sure that the aircraft is right in front of the hub. You'll see that on the screen. It's a little bit low at the moment, but a bit of wind there, so that's moving the drone around slightly. Yep, so here we are back pretty much absolutely at the front. It's an important part of the process. Now I'm setting the right hand distance scale to 10 meters, and that tells the software that the drone is 10 meters from the core of the blades. It's 7.7 meters from the hub, but the blades are behind that, so we're set to 10 meters. Once I'm happy with that, I can press the blue tick button again, and that will bring up the final turbine setup dialog. Some of those things I can change if I want to, such as the distance I may wish to fly from the blades themselves. Or I might also want to change the blades that I'm going to fly in this particular mission. So each individual one can be switched off if required. Once I've saved that and I'm happy, I can upload the mission, all of the waypoints uploaded to the drone. You can see the progress in the top left hand side. That takes just a moment. When I'm happy to start the mission, I press the start mission button. The drone will back away from the turbine a little way, to about 10 meters or so. I've just turned on the small FPV camera. This will give you a good view of how close or far away the drone is from the turbine itself. It looks very close, of course, in the main camera, but with the FPV camera, you can clearly see that the drone is in a safe position and well away from the upper blade. At this point, the drone is moving round to the first pass, which is the start of the suction side pass of blade A. Now we've got the opportunity to look at this from the ground. So the drone is just backed away a little bit from the hub, as we saw in the earlier recording, and it's starting its transitions round to the start of the first pass. It's just passing underneath the blade there, to around about 6 or 7 meters from the blade, so it's well clear of it, but it looks quite close when you're seeing it from the ground. The drone now has arrived back at the start of the first pass of blade A. And we go back to the main recording here. I'm making some final exposure adjustments to make sure the EV value is between 0.3 and 0.7. And I'm keeping the blade to the right hand side of the photograph because as we come down, I want to make sure we're capturing the whole blade. Now I've paused the mission at this moment because the EV value was above what I wanted. Going to get it back to the 0.3 or 0.7 level for the right sort of exposure for the final photographs, and continuing the mission. I'm using the camera yaw to make slight adjustments to make sure that the blade stays in the center of the photographs. As you can see, the drone is flying at approximately 1.1 or 1.2 meters per second. So the aircraft will continue down the blade until it reaches the bottom. It will stop automatically and then start to transition, ready for the start of the next pass. It moves around in two 45-degree hops until it's pointing directly onto the front of the downward blade. It just takes a moment for the gimbal to stabilize. But there we are, back at the front, pointing up the leading edge. And I'm going to make some more exposure adjustments because there's a very bright side and a very dark side to that blade, so I don't want to be too dark. I've made my exposure adjustments and I press the blue mission continue button, and the drone will then climb up the blade. Again, I'm using the camera yaw control just to make sure that the blade is right in the middle of the picture. And I'm also keeping a close eye on the exposure level to make sure we don't wash out all the details on the lighter side of the blade there. So we get to the top and I'm happy that the exposure is good. Again, the drone stops automatically, but then continues on to the start of the next pass in two 45-degree hops, arriving back at the front of the hub there, and then one more 45-degree hop until it's facing the front of the pressure side of that blade. Now at this point it is quite windy there, and some of the air pressure changes are causing the drone to drift slightly high. Now if you're concerned about that, you can always pop the small FPV camera on just to make sure you're happy that you aren't in any danger. I think we're happy that that's the case. So I'm setting the exposure level to make sure that it's bright enough, it's obviously the shaded side of the blade, and then I press continue, and the blade is happily right in the middle of the photograph there. Probably not bright enough, so I'm going to make some slight exposure adjustments again before pressing the continue button, and we continue down the blade. So as before, the aircraft is flying at 1.2 meters per second, which is a result of the fact that we've set the distance between images at 2.5 meters, and it's taking an image every 2 seconds. So the end of the pass was reached there, and the drone is moving around in 2 more hops to pick up the trailing edge of that blade. When it gets there, the camera is automatically gimbaled slightly upwards. This is because we want to get a photograph of the underside of the nacelle when it gets there. So this is an automatic process. It's slightly higher than the other pass was, but that's absolutely fine. The blade is in the middle of the picture. It's bright enough, and we're going to continue the mission on up to the top of the blade. So remember, we're exposing here for the trailing edge of the blade, which is the right hand side part there. So it's worth bearing that in mind so it's not too dark. We want to get enough detail to be able to see any issues. And the drone is now reaching the top of that pass. It's stopped in the right place. I've paused the mission so that I can make a couple of exposure adjustments just to get an extra image there, take a manual image just to make sure we have a nice bright image of the bottom of the collar there, of the root. And then I resume the mission, and the drone will then fly back to the front of the turbine to its home position. Now at this point we can be asking the technician to return blade A to its parking position, and then be pitching blade B to 45 degrees. So that's what we would normally ask the technician to do. In fact, that's not been the case this time because I didn't want to fly overhead the technician, so I've waited to ask him to do that. You'll see that in a minute, because we're going to watch the blade do the pitching action when the drone has worked its way to the start of the next pass. So here we are, it's turning around now. It's going to reverse back, ready to begin the first pass of blade B. At this point the camera gimbal is settling down. As you can see, it's settled to yaw value of around about 3 degrees. And so what I'm going to do now is to yaw the camera back left and pitch it down a bit so that we're ready to take the 2 or 3 manual images we need to take of that root section of the blade. I'm making some adjustments to the exposure. I'm actually waiting here for the engineer to pitch the blade to 45 degrees. It's just pitching around now, you can see it rotating. When it's reached 45 degrees, I'll be able to take a manual image of that part of the blade. So there we go, take a manual image and yaw the camera around and pitch it up a little bit so I have an overlapping image. We'll do 3 or 4 images in total until the camera has been yawed back to the place where it started, which will be a yaw value of around about 3 or 4 degrees. When we've reached that point, we don't need to take a manual image. We can actually just have the camera pointed in the right direction, set the exposure level correctly, and when we resume the mission, the software will automatically take a photograph. So here we go. See, the sun has now gone in, unfortunately, so we need to pause the mission and we need to make some further exposure adjustments to get the exposure back to a sensible level of around about 0.7 on the EV, and then we can continue the mission. So I'm keeping the blade in the picture, in the middle of the picture, using the camera pitch control, and I'm waiting for the tip to appear because I want to make sure that a couple of photographs have been taken of the tip. So I'm confident with the tip finishing there that it will have taken the photographs necessary. If required, we can pause the mission and take some additional photographs, but in that case we didn't need to. Because I didn't pause the mission continued and the drone is repositioning itself ready for the next pass, which is the leading edge pass. Now, the blade isn't actually in the picture here, so I'm going to need to yaw the camera around to the right just to find it there, to get it in the right position, make some exposure adjustments so it's not too dark, say -1 or something like that, and then press the continue button and the aircraft will automatically fly down the blade. I'm going to keep an eye open for the exposure not getting too bright, and then if necessary I'll pause the mission and make the adjustment. A bit bright there, I think. Darken it a little bit and continue the mission, and at some point soon the root of the blade and the hub will appear, and that will be the end of the pass. There we go. And the drone will now reposition itself down in front of the turbine but looking upwards so that it can take images of the pressure side of blade B. Now it's down below. So I shall use the camera yaw and pitch just to get the blade in the right place. We'll need to brighten up the image quite a bit because it's on the underside, so it's shaded. EV value in this case of around about 2 because of the strong backlighting is about right. As you can see that the colour and brightness of the blade in the picture is good. We're going to let it continue up to the end of the blade. In this case I've got the little FPV camera turned on, so you've got a view of what's happening there as well. Again, I'm watching to make sure that the tip is fully included. I'm happy that it was. Yep, I'm right into the bottom right hand corner of the picture, and the camera was still running, so I'm sure we'll have those images. And so the drone will automatically now move to its next pass. The final pass is the trailing edge pass of blade B. It's going to turn around to the right. We may need to make some slight adjustments again to make sure the blade is in the picture. There isn't really room at the moment for the FPV camera, so I'm going to turn that off, and we're adjusting the exposure for the trailing edge of that blade. I'm not interested in the top surface, which is a bit bright, but we're interested in the trailing edge. So now we are running down the blade, trying to keep the blade in the middle of the picture using the camera pitch. And as the blade reaches the towards the root, it's actually near to the nacelle, so the mission is automatically paused so that the aircraft doesn't fly into the nacelle. So here it's necessary to take 2 or 3 additional manual images, so I'm making sure the exposure is right, but I'm taking 2 or 3 overlapping manual images to include the collar and the root section of the blade right by the nacelle. And once I'm happy that I've got a correctly exposed photograph there, I'm actually going to reset the, once the photograph has been taken, I'm going to reset the gimbal to point forwards, and then I'm going to continue the mission round to the other side of the turbine. And I've put the FPV camera on so you can see exactly what's happening. So again, this complete transition happens in 45-degree hops. The next one will bring us round right to the front of the turbine, so the cameras will be pointing at the hub. That's done a good job of getting us back right to the home position of the aircraft. 2 more hops round to get us right to the back of blade C, which will be the first pass, which is the suction side pass. Again, the technician needs to be putting blade C into the 45-degree position. As it turns out, once more it would have been unsafe for him to do so. So I've waited, and so at the moment the blade is still in its 78-degree or 90-degree position, and so we're having to wait for the technician to make that adjustment, which is a bit of a delay. Here it goes now. It does give us an opportunity to set the exposure, ready for the photographs of the underside of that blade. And because we're again close to the nacelle, we need to take 2 or 3 manual images, and then yaw the camera back to roughly 0 degrees. So that's our first manual image. I'm going to take another one, overlapping, and it'll take 2 or 3. So you can see the yaw value of the camera gradually getting down 7 degrees at the moment. I'm going to make one more adjustment to the gimbal. We don't need to take a manual image because we can press mission resume, and the camera will automatically start. And then, as before, the drone will successfully run itself up the blade. You may need to make some slight adjustments to the camera pitch to keep the blade right in the middle of the picture. You can either do it on the fly, or you can pause the mission in order to make any changes that you need to do. You're keeping an eye open for the tip to appear. It did appear, but it was actually not too far down. So I paused the mission immediately using the pause button. I moved the gimbal back, and now I'm going to take an additional manual image to make absolutely sure we have that tip. Then I've pressed mission continue, and the aircraft is going to move round to the next pass, which is going to be the leading edge pass for blade C. So there we are. Again, we won't need the FPV view, so turn that off. It needs to be reasonably bright because we want to make sure we get the detail in the leading edge, but not too bright. So an EV value of, with cloud behind, of around about 1.7 or 2 would be plenty. I think that's well exposed. Mission continues, having pressed the continue button, and the drone will progress down the blade. We'll keep an eye open to make sure that it's still bright enough on that leading edge. Maybe that we need to pause it and make it slightly brighter just to be sure we've got good detail. Mission is paused there, so I'm making it slightly brighter for the last 2 or 3 images down to the hub. So that's fine, it's a good image, it's nice and bright, not too bright. So the drone now positions itself for the next pass, which is at the front of the turbine but looking down towards the pressure side. So it's going to climb up a bit and point the camera down to the pressure side of blade C. It's bright on that side of the blade, so we need to make exposure adjustments. And when we're happy with that, we can press the continue button. So all we should really need to do here is to make some slight adjustments perhaps with the camera pitch value to keep the blade correctly in the middle of the photograph. And we're watching out for the tip to appear. Be absolutely sure. If we're not absolutely certain, pause the mission like that. Take an additional manual photograph to make sure we definitely have that tip, and then continue the mission. So this is the final transition. The drone is moving itself into a position over the top of blade C so that it can look down on the trailing edge. So it's putting itself into position. The mission is now on pause, and we can see the blade in the picture there. We're going to make sure that it's exposed correctly, and then we can press continue, and the drone will work its way down the blade, possibly needing slight adjustments to the pitch of the camera and watching for the exposure not getting too bright. But that's all looking good. Now the drone is approaching the cell again this time, so it will pause, as it has done there, and we'll need to take 2 or 3 additional images, overlapping images, manual images, to cover that area where otherwise it will be missed. Take another manual image, keep yawing the camera around and making any pitch adjustments we need to make so that the image is good, the exposure is correct. We take a couple of photographs there, and that finalizes the data set. So we have all the images that we need. So now we can continue the mission, pressing the continue button, and the drone will fly back round to the front of the turbine. Now, had we wanted to, we could have flicked the mode switch at that point. If we'd been able to see the drone, we could have flicked the mode switch and backed the drone away from the turbine and landed it behind the turbine. It all depends where you're standing. So in this case, the drone is automatically flying back to the home position. I've reset the camera using the gimbal recenter button. As you can see, the aircraft is now arriving at the front of the turbine. It's giving a message saying that the mission is completed, and now the drone is automatically back into manual flight mode in PGPS mode, so GPS stabilized mode, and we can back the drone away from the turbine and bring it in for a landing. And that's the mission completed. I'm going to turn away a bit so I can fly safely away from the turbine and back down to the ground. We're starting to get close to the level where the battery warning will come on. It's taken a bit longer than normal to do this flight because it's a demonstration flight. Normally you'd hope to be able to get down with maybe 25 or 30% battery. But there we are, that's the complete mission.